Okay, this is Algebra 2. We're going to be going over lesson 118. This is going to be more on logarithmic equations. All right, so let's think here. We're going to be looking at some logarithmic equations. We're going to have some examples. Say, let's get rid of the highlighter from last time. All right, so we're going to have log x plus 4 and say log 3. Okay, well, the x plus 4 and the 3 are what we call arguments. Okay, so these are going to be arguments. All right, so I want you to think about something. Remember before that if we had 10 cubed times 10 squared, we would make this 10 to the 3 plus 2, so it would be 10 to the 5th, right? So when we've got the same base and it's being multiplied, we wind up adding our exponents. And remember that if I have 10 cubed divided by 10 squared, that equals 10 to the 3 minus 2, which is just going to equal 10 to the 1. All right, and then finally remember that if I have 10 cubed and I square it, that is equal to 10 to the 3 times 2, or 10 to the 6. Remember that? All right, so if logs with the same bases are added, the arguments are going to be multiplied. All right, so if I've got, I'm going to come up here and do this log, which is going to be base 10 of 5 plus log base 10 of 7 is going to equal log base 10 of 35. All right, so think about that for just a moment. Here, remember with the log that I'm finding with this, what do I have to take? 10 raised to what number is going to give me 5? 10 raised to what number is going to give me 7? Remember, that's kind of what I've got going on there, right? Okay, so over here, I had 10 raised to the 3 times 10 raised to the 2 is going to be 10 raised to the 2 plus 3. Okay, so I took right here, I added my exponents. Okay, when I was multiplying my bases. So now over here, when I add my bases, I'm multiplying my logs. All right, so you've got a similar sort of relationship there, that the addition goes with the multiplication, just like over there, the addition went with the multiplication. Okay, if logs with the same bases are subtracted, then the arguments are going to be divided. All right, so if I've got log 3, log base 3 of 14, minus log base 3 of 7, all right, and this is going to equal log base 3 of 2, because 14 divided by 7 is 2. All right, if I had log base 3 of 7 minus log base 3 of 14, this is going to be log base 3 of 1/2. I'm going to take the 7 divided by 2. Okay, so similar sort of thing over here. Originally, I'm taking base 10 cubed divided by base 10 squared. I'll subtract my exponents. Here, my logs are being subtracted, so I'm going to divide the logs. All right, similar sort of math. All right, so let's look down here one more. If my logs are going to be multiplied by a constant or a variable, the argument is raised to that power. I'm going to write this out for just a second. If well, actually, let me show you. I'll show you an example and then we'll write it out. Okay, so if I have 4 times log base 4 to 100, this is going to be log base 4 of 100 to the 4th. All right, if I have x, well, I'll hold on to that for just a second. Let's look at this. So here's the deal. If logs are multiplied, by a constant or variable, which that 4, that's going to be the constant, or a variable. Okay, and that was going to be that idea. Let me go ahead and put this here where I've got x times log base 4 of 100. All right, so here in this first one, the log is being multiplied by a constant. In the second one, the log is being multiplied by a variable. So if logs are multiplied by a constant or a variable, the argument is raised to that power. The argument, okay, and this over here is the argument. Remember, I had shown you when we began this right here, I showed you this, and I told you that these right here are my arguments, okay? So if the logs are multiplied by a constant or a variable, the argument is raised to that power. All right, and so similar here, so I'm winding up taking my log, I'm multiplying it by something. Therefore, I'm going to take my log and raise it to that power. Okay, so over here, back at our original, if I have an exponent and I raise it to another power, I multiply them. All right, so again, you've got very similar math that's going on. All right, so here's just a kind of simplified reference for you. Let's look at this as you just kind of reference. You might want to make sure that you copy this down. Okay, so I've got this condensed idea. And then expanded. Okay, so if I have log, I wrote that wrong. Okay, so if I've got log base b of m times n, that's the same as log base b of m plus log base b of n. All right, and this can go either way. All right, so in the example I showed you a minute ago, we started with the expanded version, okay? We started here. If I have these two logs right here and they're being added together, I then just multiply what I'm taking the log of. All right, and so here you can go either way. If you've got something like this, you can expand it, or if you've got the expanded version, you can condense it. All right, here my condensed version is log base b of m divided by n is going to be log base b of m minus log base b of n. All right, and that can go either way, whichever one you already have. If you have the condensed, you can expand it. If you have the expanded, you can condense it. Okay, and then log base b of m to the n is equivalent to n times log base b of m. Okay, so you want to be able to move either direction with those. That you know, if I see, okay, so if I see log bm plus log bn, I know I can solve it by multiplying the arguments. I can solve this by log base b of mn. All right, so a rule for you to make note of. Here's a rule. All right, so don't you like how I spelled rule? I was busy looking at the fact that I tried to write log and I wrote lob. All right, so here's a rule for you. Do not follow the way that I necessarily write things. So this one up here should be log base b, and down here we're going to write a rule for you. All right, if the bases are the same, if the bases are the same, and the logarithms are equal, and the logarithms are equal. We've got an if-then statement. Then the arguments are equal. All right, and if you take a moment, just think about that. If the bases are the same and the logarithms are equal, then the arguments are equal. Okay, so if I have, think about this, 7 squared equals 7 squared, right? All right, if I've got then log base 7 of x equals log base 7 of y, then I can cancel out my log base 7s, cancel those out, and I can see that x is equal to y. All right, so if I've got log base 5 of x plus 4 equals log base 5 of 7, I can cancel these two out and say that x plus 4 equals 7 and that x equals 3. All right, you do want to take this right here. I've gotten this 3. You can then take that, of course, and, plug it in up here to be sure that your argument is positive. All right, that 3 and 4 over here, 3 plus 4 equals 7. All right, you cannot have a negative argument. So you do need to make sure that your arguments are positive. So do plug those numbers back in just to make sure that you've got everything correct there. All right, let's look at another example. If I've got log base 5 of x plus 8 plus log base 5 of 4 equals log base 5 of 80. All right, well, let's go ahead and take this over here. This is an expanded version. Let's take this over here and let's condense that, right? So this is going to be log base 5 of 4 times x plus 8 equals log base 5 of 80. All right, so now I can cancel the log base 5s out, and I get that 4x plus 8. Hold on, sorry. All right, I'm going to get this 4x plus 8 equals 80. Go ahead and distribute this, and I get 4x plus 32 equals 80. 4x equals 48, and x equals 12. All right, so then when I take this 12 and I plug it back in up there, 12 plus 8 equals 20. 12 plus 8 equals 20. So my argument is positive, so yes, this is good and this is fine. All right, let's look at this. Let's look at another one. If I have log base 7 of x plus 7 minus log base 7 of x minus 2 equals log base 7 of 10. Okay, so we want to take this side over here and let's condense these. All right, remember these are being multiplied, these are being subtracted, therefore I'm going to divide them. So I'm going to be able to have log base 7 of x plus 7 over x minus 2. Sorry about that. I love my little thing, but at the same time, sometimes it decides to create shapes. Okay, so I'm able to condense this over here, and then over here, this side is log base 7 of 10. All right, so now I can cancel these out, and I've got x plus 7 over x minus 2 equals 10. Let's multiply both sides by the x minus 2 so that we can get rid of the denominator. All right, so this is going to cancel here. So now I'm left with over here just the x plus 7 equals 10 times x minus 2. X plus 7 equals 10x minus 20. Let's bring this x over here to give us just 9x, right? Let's bring this 20 over here. It's going to give us 27. And so x equals 3. All right. And if we think back up in here, if we plugged an x in, back here, if we plugged a 3 in, 3 plus 7 is 10, and the 3 minus 2 is 1, so those are going to give us positive numbers, so that is just fine. Okay, let me show you one more real quick, and then we will be done with this. All right, if I have 2 times log base 3 of x equals log base 3 of 16. Okay, so remember when I'm multiplying a log by a number, I'm going to wind up raising the log by that same number. So now I'm going to have log base 3 of x squared equals log base 3 of 16. I can cancel these out so that I get x squared equals 16. All right, so now let's take the square root of both sides, and we're going to get x equals plus or minus 4. All right. So let's think about that for just a second. Okay, so if I've got this 2 times the log base 3 of x and x is 4, that works. But 2 log 3 negative 4, that does not work because my argument can't be negative. So the answer is actually just going to be x equals 4. It's just the one, not both of them. Okay? All right, I hope that helps, and you guys have a great rest of your day.